Okay, this is chapter 7, lesson 9, more uses of the r sine x plus alpha formula, or the r cos x minus alpha formula. If you haven't watched lesson 8, you need to watch lesson 8 before you watch lesson 9. Okay, let's get cracking. So we're going to express 7 cos of x plus 8 sine of x in the form r cos of x minus alpha. I did some justification about why it is that you might want to do that in the previous video. If you haven't watched it, watch it. So we know that you've got 7 cos of x plus 8 sine of x is going to equal r. Well, cos of x minus alpha is going to be cos of x cos of alpha minus, for cos in the brackets would be a plus in the formula, so we're going to have a plus here, sine of x sine of alpha, and we're going to expand in this r, so we get r cos of x cos of alpha. I'm using alpha, but it says a up here, it shouldn't really matter. It's just because I couldn't find an alpha symbol. Sine of x sine of alpha, so there's the expansion. Now by comparison you can see that 7 goes with cos x, also r cos alpha goes with cos x, and so therefore 7 must be equal to r cos of alpha, and 8 must be equal to r sine of alpha. Okay, remember that from previous lesson. Part 1 for this, we're going to work out the tan bit, so we'll get r sine of alpha equals 8. I'm going to put that over r cos of alpha equals 7. Okay, now if this is equal to this and this is equal to this, then this over this must be equal to this over this. Okay, that's the rationale behind it. So we get tan of alpha equals 8/7. Alpha equals tan to the negative 1 of 8/7, which means that alpha is equal to 48.81 degrees. Of course you can have these with radians and whatever else, it's just that I haven't written any questions with radians just yet. So there we go, we've got alpha. Next for part 2, it's all of this stuff is going to get squared, so we're going to have 49 is going to equal r squared cos squared alpha, and 64 is going to equal r squared sine squared alpha. I'm going to add the right to the right and the left to the left, so I'll get r squared cos squared alpha plus r squared sine squared alpha, which I'm going to factor out the r squared, so I'll get r squared cos squared alpha plus sine squared alpha. So that's this plus this with the r squared factored out, and the left hand sides are 49 plus 64, okay, which is 113. This adds up to 1. We should know that from year 1. R squared therefore equals 113. R equals plus or minus root 113. R equals positive root 113, as R is greater than 0, as specified up here. Okay. Now we've got that, and we can express it in that form, and the form would be root 113 cos of x minus 48.81. Okay, now that there is just stuff that you should know from the first lesson on this chapter. Okay, we're going to try to use it in some different ways. So we've got root 113 cos of x minus 48.81. Okay, now this says solve that chunk of maths. Now that chunk of maths was the first part up here. Okay, that chunk of maths could actually be written like that. We're saying that that chunk of maths needs to equal 8. Okay, so what we've got is root of 113 cos of x minus 48.81 has got to equal 8. Okay, and we're doing that for x going from 0 up to 360 degrees. So things that you should know is that you can strip away everything you want, okay, from this, and then the cos can go, but this little bit of information here has to stay as it is for quite a while. Okay, so we're going to get x minus 48.81 equals cos to the negative 1 of 8 over root 113. Cos to the negative 1 of 8 over root of 113 comes out as 41.186. That's x minus 48.81. Do not do anything with this just yet. Once you've got this value out of cos, we know that we're going to be heading towards getting a few values, a couple. Once you've got that value out of the cos to -1, you need to find every other candidate value with cast. And then after you find every candidate value with cast, then you add on 48.81 to every single one of them. You have to find all of the candidate values before you do. And that goes for if you've got a question that's got, say, like a 2x in here or a 2 theta or something like that. If that happens, it should have a 2 here, it should have a 2 here. Find all your candidate values and then solve each one of them. Add on 48.81 and divide by 2 in that case. Okay, we have to cast this first and then add on the 48.81. Now, with this, we're going to be adding on a value. So when we come to casting, we're not just going to use the 0 to 360 degrees for cast. We're actually going to go back a bit, because you never know, we might go back a bit and then add on, and that might take us just over 0. Okay, there's a good clue for it. It's obviously that I'm talking about it. That's one of the clues, because I wouldn't be talking about it if I didn't think it was important. And I've doctored the question, so it does that. You see, I'm going to add on 48.81 onto this, but also with cos, I'm going to get negative 41.186. And when I add on 48 odd, I'm going to get over. Okay, so we'll have a look at it now. So we've got 41.186. We've also got the negative version, okay, because we're in cos, cast from cos. Okay, so we're going to get negative 41.186. And we're also going to get the one that's quite close up to 360 degrees, which is 318.814. I don't think we need to go any further than that. If we went past 360 degrees, we're only going to end up adding on to it, and so it's going to take us even further past 360 degrees. We don't need to go, obviously, back all the way, like past negative 91.8270 to whatever that would be, okay? Negative 318.814, wouldn't it? So we don't need to go that far back, but we do need to go back a quadrant. It's important that we do. Now we're going to add on 48.81 to every single one of these things, okay? Now I've got all my candidate values, I'm going to add 48.81 onto each of them, okay? So we've got 48.81 plus 41.186. Really, I should have stuck with 3 decimal places throughout, but I didn't. And that's going to come out as 89.996. Okay, 89.996. Yeah, good. Okay, we've got negative 41.186. So negative 41.186 is going to be added to. We're going to add on 48.81, which is going to be 7.624. Now with the last one, 318.814, 318.814 plus 48.81 is going to come out as 367.624, 367.624, 624 that was. That is too big. It's outside the range, and so outside the domain for x. And so with our x, the stuff that fits into the domain for it will be 7.624 degrees and 89.996 degrees. Okay, things I could have done better with that was I've mixed together 2 decimal places and 3 decimal places. That could have been a little bit better, certainly, but hopefully that's okay. All right, the gap between those is roughly 82. The gap between these would have been roughly 82 as well. That's quite a nice thing to spot. All right, moving on. Give the maximum value of the exact same question that we've been doing all the way through and the smallest positive value for x for which it occurs. So we've got finding the maximum value of root 113 of cos of theta minus 48.81. Well, the maximum value of that is going to be root 113. Okay, this r here is a scalar. If there wasn't one there, it would be a 1, and 1 applied to the cos wave will still just come out as a maximum of 1 and a minimum of -1. This here is just a scalar. All it does is just stretch out the cos wave, so it might take it from looking like that to being, looking like that, but it doesn't do anything with kind of the squeeze of it, the horizontal squeeze of it. Okay, so what we know is that the maximum is going to be root 113. That there is going to be the max. All right. Really though, you could pretty quickly spot that you can just deal with this information here. Okay, cos to -1, is cos of negative 1 of 1, pardon me, is 0. So you get theta minus 48.81 equals 0. If you really wanted it, the next one along is obviously 360, etc, etc, etc. Okay, 360 if you really wanted it, but you're not going to need it. Okay, and the other one, negative 360, again, you're not going to need it. You're going to want this one. Add on 48.81 and you'll get theta equals 48.81. Take a look at it. If I chuck 48.81 into there, I get cos of 0. Cos of 0 is its maximum, isn't it? Okay, there, that's the maximum for it. So that just makes sense for it. Okay, hopefully that's okay. Your tasks are 7, 8, 9 and 11 with 12 and 15 as an extension. As I mentioned in one of the questions just earlier, if you've got something that's like cos of 2 theta plus 15 equals blah blah blah, work out 2 theta plus 15 equals cos to the negative 1 of, I'll call this A, cast that and then take off 15 and then divide by 2. Obviously this should be a negative. Okay, just watch out for that because that's in a couple of the questions that I'm giving you to do. But I think you're clever enough to figure it out. Take a picture, pop it up on Google Classroom for me, let me know if you're stuck on anything. Hopefully that's okay. Thanks very much.